Hey class, so in this video we are going to go over Chapter 8, which is all about deductive arguments. Start here. All right, so if you remember, in the previous lesson, Chapter 7, we talked about inductive arguments, and we learned just how prevalent inductive reasoning is in our daily lives, almost a cornerstone of human existence practically. But deductive arguments find their way into our personal lives as well, and they definitely find their way into argument. And it's important to have really good critical thinking skills when you're dealing with deductive arguments, because they can be tricky. Now, one thing I will say before I get any further into the PowerPoint is that in this lesson, the PowerPoint and the video, we are not covering all of Chapter 8. We are going to cover the first section for sure. What is a deductive argument? The second section, types of deductive arguments, we're going to look a little bit at that. And then we will look at hypothetical syllogisms. The rest of Chapter 8 is very technical. It gets into diagramming deductive arguments in a way more complicated fashion than what we did in Chapter 6 with diagramming regular arguments, just looking at the propositions, the premises, and the conclusion. The second half of Chapter 8 gets into some really detailed, somewhat confusing information, and I just don't think that we need that for our purposes in this class. However, if you are going through the first part of Chapter 8 and deductive arguments sort of tickle your fancy, feel free to read the rest of Chapter 8. But I am not expecting you to, you are not required to, and you will not need to have gone through the rest of Chapter 8 to do the homework for this week. Okay? All right, so let's just go ahead here. We start off with a nod to Sherlock Holmes. I have a quote here from Sherlock that says, "When you have eliminated the impossible, whatever remains, however improbable, must be the truth." It's this idea that, you can use logic not always to find the answer, but to eliminate the wrong answers. And whatever you're left with, that's the truth, even if it seems crazy, right? And Sherlock, he is sort of the epitome of a skilled reasoner. He uses logic and both inductive and deductive reasoning to solve his cases. So we're going to take a look at what deductive argumentation is all about. Right? What is a deductive argument? So first, let's kind of recap a little bit what we learned in Chapter 7 about inductive arguments. So if you remember, we use inductive argument all the time. And the reason is because there's so many unknowns when we are looking at an issue. We cannot tell the future. We don't know what's going to happen. So we use inductive argument to come up with the most likely scenario. So in that respect, inductive arguments, the premises, the reasoning behind the argument, the support of the argument, only offers us support and likelihood. It does not offer proof for the conclusion. However, in a deductive argument, the conclusion necessarily follows from the premises, meaning we have no choice but to accept the conclusion, right? So that is for a valid deductive argument. If it is a valid deductive argument, we really have no choice but to accept the conclusion as true. And that's kind of what Sherlock was hinting at. When you take away everything else, whatever you're left with, however improbable, is the truth. Now, that's a valid deductive argument. We're going to come back to that word here in just a little bit. But if it is a valid deductive argument, the conclusion must be true. So in that respect, deductive arguments do offer proof, not just support, not just likelihood or probability. It offers proof. There are certain words or phrases that are commonly used in deductive arguments, such as certainly, it is certainly true that, or it is absolutely true that, it is definitely true, conclusively, it must be true, it necessarily follows that. So those are the types of words and phrases that indicate that you're dealing with a deductive argument. And again, these words aren't only used for deductive arguments, but they show up a lot with deductive arguments. All right. So one of the hallmarks of deductive reasoning is something that we call a syllogism. So deductive arguments are often presented in the form of syllogism, where there are two supporting premises and a conclusion. And we have an example here. Our first premise is all men are mortal. We have another premise. John is a man. Our conclusion, therefore, John is mortal. Now notice we have to have both of those premises. We can't just say all men are mortal, therefore John is mortal. We have not established that John is a man. We can't just say John is a man, therefore John is mortal, because we haven't established yet that all men are mortal. So you need both premises in order for the conclusion to have weight and be true, right? So when we have those two premises, and sometimes there might be more than two, those are what we call dependent premises, meaning they all depend on each other to be present in the argument in order for the conclusion to be true, right? So the first thing we want to look at with deductive arguments is whether or not they are valid or invalid. So if an argument is valid, if a deductive argument is valid, it simply means the form and pattern of reasoning in the syllogism are such that the conclusion must be true if the premises are true. And at this point, we are assuming the premises are indeed true. So we look for validity first before we look at the actual information and whether it's correct and accurate. So we're looking first at just the premises and the form in which the argument is presented. We will come back to the truth of the premises in just a moment. But for now, we're only looking to make sure that the form and the pattern of reasoning is such that the conclusion must be true, right? So the form of an argument is determined by its layout or its pattern of reasoning, how we get from point A to point C or point D, right? So looking at our previous example, we have all men are mortal. John is a man, therefore John is mortal. You notice how the conclusion uses the same terms that are in the premises, and we follow a specific pattern. So we have all men are mortal. So X, Y. John, that's a new term, so that's V, is a man. So man was X. That was the first term we mentioned, right? Therefore, John, V, is mortal. Mortal was the second term we used, so it's Y. You can see X is to Y, Z is to X, therefore Z is to Y. And no matter what terms we substitute in those sentences, the argument will be valid. The conclusion is valid. So you have to take that form, and it has to be that way every time in order for the argument to be valid. All right, so xy, zy, zx. All right, so how does an argument become invalid? And again, we're not even looking at if the statements are true yet. This is just all about the form. So how does an argument become invalid? Well, when the form and the pattern of reasoning don't support the conclusion. So remember our form, x equals y, z equals x, therefore z equals y. So here's an example of a valid deductive argument, but a false conclusion. All men are tall people. Tom Cruise is a man. Therefore, Tom Cruise is a tall person. You can see we have the correct form. X equals y, z equals x, z equals y. Now we know that this is wrong. We know that that conclusion is false because we know Tom Cruise is not a tall person. But again, we're not concerned with the truthfulness yet of the premises. The reason this is wrong is because all men are tall, all men are tall people. That's not true. But again, right now we're just looking at whether the argument is valid. Does it follow the correct form? Is the pattern of reasoning solid? It is. This is a valid argument, right? So what about this one right here? So this is going to be an example of an invalid deductive argument that is due to faulty form and logic. So remember, Tom Cruise example, the logic was not faulty, therefore it was a valid argument. In this example, the logic is faulty, right? All dogs are mammals. Some mammals are not poodles. Therefore, some poodles are not dogs. Well, we know poodles are dogs, so, but again, that's just because this is an easy example and we're familiar with the terms already. But, what if we weren't familiar with dogs and mammals and poodles? How would we know that this is an invalid argument? Again, we're looking at the form. And look, this is right here. This is our form for a valid deductive argument, right? X equals y, z equals x, z equals y. But if you look at the form of this example, x equals y, y equals z, z equals x. So the second premise, the form, is faulty. It's supposed to be z equals y. And you think it wouldn't matter because if z equals y, then y equals z, right? But no, it's not math. It's logic and reasoning. And so because we switched the order of our terms there in the second premise, it causes the whole argument to fall apart, right? Okay. So now we have an example of an invalid argument that is going to seem valid because we're going to know the conclusion is true. Again, when you're not sure of the topic being argued, then you're not going to know that the conclusion is actually true, even though the form is invalid. So don't let that confuse you that here you're going to think, oh, this is valid because I know that conclusion's true. No, look at the form and substitute the terms. So what we have here is no seniors, X, are freshmen, Y. All freshmen, Y, are college students, V. Therefore, some college students, V, are seniors, X. So we have X equals Y, and again, Y equals Z. Therefore, Z equals X. The form is off, but it would be really easy for us to think that this is a valid argument because some college students are seniors. They got lucky with this one, that the conclusion still happens to be true, even though the form of the argument is faulty. And how do we know this? We substitute terms for X, Y, and Z and see if it still holds up. right? So, I mean, we know if we're thinking about the form, we know that this went X, Y, Y, Z, Z, X, and we know that's wrong. We should be able to tell right away that this does not follow the correct form and pattern of reasoning that a deductive argument should have. But just to make sure, let's substitute some terms and see if we still get that true conclusion, or if we were just lucky. So we're using fish, dogs, and mammals. So no fish, X, are dogs, Y. No dogs, Y, are mammals, Z. Therefore, some mammals, Z, are fish. Oh, yeah, no, that's not true. All right, so even though this version up here with our freshmen and seniors, even though that one happened to give us a true conclusion, it is an invalid argument because it does not take on the correct form. The pattern of reasoning is incorrect. And we know this for sure, not only by looking at the pattern of the terms, but also substituting the terms. Okay. So just to recap, right? We've got our pattern for a deductive argument, X equals Y, then Z equals X, Z equals Y. We can see what happens, how we have a valid argument, even though we know the conclusion is wrong. So again, validity is just the form and the pattern of reasoning. This argument is valid because it follows the correct pattern. This one here with dogs, mammals, and poodles, this one is invalid and has a false conclusion. The reason is because the pattern of reasons are wrong. It's faulty. And over here, we had a lucky true conclusion, but still an invalid argument because, again, the pattern of reasoning is faulty, not correct. So, again, when we're talking about the validity of a deductive argument, we are only talking about the form and the pattern of reasoning. The pattern, X equals Y, Z equals Y, Z equals X, right? If it carries that form, it's valid. If the form of the argument appears to be valid, meaning the form is on point and the logic appears to be solid and it follows the correct pattern, the next step, if we have a valid argument, is to look at whether the argument is sound. And that is where the truth comes in. So an argument is sound if it meets both of these criteria right here. The form and the logic of the argument are valid, so it has to be valid first. Then we check to see if the premises are true, right? So it's basically like saying, we want to make sure that this is a logical argument first before we waste any more time deciding if the premises are true, because maybe that's going to take some research, right? It might take some research to make sure that every premise is true and accurate. Well, why would we even do that if we don't know yet if the argument is even valid? So we look at the form first. We look at the form, the logic, and the pattern of reasons to make sure it's valid. Once we know it is valid, then we start looking at the premises. Are all of the premises true, right? Logic is primarily concerned with just that validity step, because that's where the logic is, right? In the pattern. But as critical thinkers, and as people who exist in the world, we also need to be concerned with the truthfulness of the premises. Just because it's valid doesn't mean we should accept that that conclusion is true. We then have to take the extra step of critically analyzing the premises, right? Okay, so our examples about the dogs, mammals, and poodles seniors, freshmen, college students, and fish, dogs, and mammals, they were all invalid due to faulty form and logic, right? Because we had true premises, but untrue conclusions because the pattern was wrong. We had for the all dogs are mammals, some mammals are not poodles, therefore some poodles are not dogs. That was an invalid argument right away because the form was wrong. Instead of being x equals y, z equals y, z equals x, this argument has the pattern of x equals y, y equals z, and then z equals x. So invalid. Our example with the seniors and freshmen, remember the conclusion actually was true, but it was still an invalid argument because it also messed up the pattern. X equals y, y equals z, z equals x. So for both of these arguments, the second premise does not follow the correct form, and therefore the whole argument is invalid even if the conclusion happens to be true. So, and then this was our example where we substituted the terms up here. Invalid arguments are always unsound because they don't meet this first criteria right here. The form and logic of the argument are valid. So if we don't meet that first criteria, it's an unsound argument, right? You don't even have to look at the premises, even still. Once an argument is invalid, that's it. It's invalid. Move on. Now, what happens when you look at the form and it's like, okay, this follows the correct pattern. We have a valid argument. Now we have to determine if it is a sound argument. Our example about John being mortal is a sound argument because the form is valid and the premises are true. All men are mortal. That's true. And it follows the right pattern, x equals y. John is a man. Also follows the correct pattern. Z equals y. And it's a true premise. John is a man. Therefore, John is mortal. That statement must be true. That conclusion, we must accept that conclusion as true because the argument is valid and it is sound. So it follows the correct form and pattern of reasoning, and the premises are true. Sound argument, we must accept that conclusion. Our example about Tom Cruise, though, is an unsound argument. Remember, that's the one where the pattern was correct, but the conclusion was wrong. And the reason the conclusion was wrong is because one of the premises was not true. So we have the correct form. All men are tall people. X equals Y. Tom Cruise is a man. Z equals X. Therefore, Tom Cruise is a tall person. Z equals Y. But all men are not tall people. That's not true. Therefore, the conclusion, not true. It is an unsound argument. All right, so now that we have a brief understanding of how deductive arguments work, remember looking first at the form to determine if it's valid. If it is valid, then we look at the truthfulness of the premises to determine if it is a sound argument. The idea, of course, the goal is to have a sound argument because it means your logic is on point and your information is accurate, right? If you have good logic and accurate information, you have a strong argument. So what are the different types of deductive arguments? We're not going to spend a lot of time on this, but I am going to talk about each type real quick and give you an example. All right, so there are three types of deductive arguments that are used in everyday reasoning. First and foremost, arguments by elimination. So these types of deductive arguments rule out different possibilities until only one possibility remains. That's definitely along the lines of our Sherlock Holmes kind of reasoning skills. We also have arguments based on mathematics, which depend on mathematical or geometric equations to generate conclusions. I don't really want to get into detail on those. Whew. Arguments by definition. The conclusion is true because it is based on a key term or essential attribute in a definition. All right, so let's take a look at very brief examples of each of these. All right, so arguments by elimination. So easy example here of deductive argument or deductive reasoning is a mouse finding its way through a maze. It uses process of elimination. If you have, looked at any Sherlock Holmes stories or the movies or the TV show, think about how he uses process of elimination to come to his conclusion. All right. Arguments based on mathematics. So something like the rover, the Mars rover, the landing, it was a result of deductive reasoning skills of NASA scientists. So they're using deductive reasoning and mathematics to ensure that the Mars rover had a smooth landing. All right, so these skills come into play all over the place. Arguments from definition. All right, so our national issue on same-sex marriage, one example of an argument against it would be Marilyn and Jessica cannot be married since a marriage is a union between a man and a woman. If you set that up as a deductive argument and the definition of marriage can be proven to be a union between a man and a woman only, then you have successfully proven that the conclusion is true. Now, if you think back to what we learned about arguments based on definition or arguments from definition is you first have to make sure that everyone is in agreement upon the definition. And that is where this issue culturally comes into play, is that it is the definition itself that is in question at times, right? So, but if you can prove that the definition is a union between a man and a woman, if you can prove that that's true, then you can prove that the argument is true, the conclusion is true. We do this a lot too. But certainly the type of deductive argument that we use on the most regular basis by far is arguments from elimination, process of elimination, quite frequently used. The last thing we're going to get into here in Chapter 8 is something called hypothetical syllogisms. So remember, a syllogism is that pattern of reasoning in a deductive argument. X equals Y, Y equals, or Z equals Y, therefore Z equals X, right? These are hypothetical syllogisms, all right? And a hypothetical syllogism involves a conditional statement. If you remember, we talked about conditional statements back in Chapter 6, I believe, where we were looking at different types of arguments or propositions and premises, and we learned that a hypothetical statement by itself is a non-argument, right? If I win the lottery, then I'm going to move to France. I'm not making an argument. I'm not making a claim. I'm not trying to prove something. It is simply a hypothetical scenario. It's just a conditional statement. If, then. You remember I said, when a conditional statement is used as part of an argument, then it becomes something more. And this is where it becomes something more, is when we are dealing with hypothetical syllogisms in deductive arguments, right? And we are actually quite adept at using hypothetical syllogisms, or at least conditional statements. It's sort of built into our brains. It's how we understand rules and predict consequences. If I drink 5 shots of tequila and drive my car, then I'm likely to cause an accident or get a DUI, right? It helps us understand consequences. If I do this, then this will happen, right? So we use that in argument because, much like with inductive arguments, we don't always have all the information, and we can't always tell the future. So that's why a conditional statement by itself isn't doesn't make a claim. It's not a premise. But when it is used in a syllogism, then it becomes a premise. It becomes part of the argument. And there are 3 basic patterns to hypothetical syllogism. You do not really have to memorize these terms, but more so the function of them. There's the modus ponens, which is where the first part of a syllogism is affirmed by the second part. So the first part is called the antecedent premise. The second part is called the consequent premise. So if, then. So if is the antecedent, then is the consequent, because that's the consequences. Then this will happen, right? So a modus ponens is where the antecedent, the if part, is affirmed by the consequent. A modus tollens is where the if part is denied by the second part, the then part. And you'll see what I mean when we look at some examples. And then a chain argument is where there's more than just the antecedent and consequence. There's there are several hypothetical conditional statements linked together. And I'm going to give you a great example of that when we get to the slide on chain arguments. There's one that's kind of popular in our culture that you will likely understand pretty well. But let's look first at the modus ponens. So remember, this is where the antecedent premise, the if part, is affirmed by the consequent premise, or the then part. So if A, then B. A, therefore B. All right? So we're saying, so if A is true, then B is true as well. Well, A is true. Well, then B is true. So if A, then B. A, therefore B. Let's look at an example with actual words. If I get a raise at work, then I will pay off my credit card bill. I got the raise at work. Therefore, I can pay off my credit card bill. So this is where the consequent affirms the antecedent. If the hurricane hits the Florida Keys, we should evacuate. The hurricane is hitting the Florida Keys. Therefore, we should evacuate. Right? You cannot deviate from that form, much like any deductive argument that we've talked about so far. Once the form is invalid, then you have what's called the fallacy of affirming the consequence. So you cannot say, if A, then B, B, therefore A. It has to be this form up here, right? You can't say, if Oprah Winfrey is president, then she was born in the United States. Oprah Winfrey was born in the United States. Therefore, Oprah Winfrey is president. You can see how because what this form is right here is if A, then B, B, therefore A. When you do that, you mess the form up, and it's invalid. You can't result with a true conclusion when you put B there instead of A in the second premise. All right. Then we have a modus tollens. This is, remember, where the first part of the syllogism is denied by the second part. So if A, then B, not B, therefore not A, right? So if Morgan is a physician, then she has graduated from college. Morgan did not graduate from college, so not B. Therefore, Morgan is not a physician, right? Okay. The second statement has to deny the consequent premise, B. And if we try to make the second statement deny the antecedent premise, A, if we try to say not A, if A then B, not A, therefore B, if we have the fallacy of denying the antecedent, it's just the form still does not work. So when you're trying to affirm, it's if A, then B. A, therefore B. If A, then B, not B, therefore not A. Right? We could go back over here and switch this up. If I get this raise at work, then I can pay off my credit card bill. I did not. Right? Okay. So just make sure that the form is correct in both of them. And again, I don't want you to get too caught up in the details of the form for modus ponens and modus tollens and chain arguments. I just want you to be aware of how they're used in deductive argument. So when we have a chain argument, it is three or more conditional propositions linked together. So if A, then B. If B, then C. Therefore, if A, then C. If it rains tomorrow, A, then the beach party is canceled, B. If the beach party is canceled, B, we're having a party at Rachel's house, B. Therefore, if it rains tomorrow, A, we're having a party at Rachel's house. Right? You can even go further. If A, then B, if B, then C, if C, then D. Therefore, if A, then D. If you don't go to class, A, you won't pass the final exam, B. If you don't pass the final exam, B, then you won't pass the course, C. If you don't pass the course, C, then you won't graduate this year, D. Therefore, if you don't go to class, A, you won't graduate this year, D. Right? It only works if you have your first conditional statement here, right? You have your antecedent if you don't go to class, and your consequent. You won't pass the final exam. The only way the chain argument is valid and works is if the next sentence starts with the consequent of the previous one. If you don't go to class, you won't pass the final exam. If you don't pass the final exam, then you won't pass the course. If you don't pass the course, we get this, like we understand the pattern. Just know that that pattern is required. It has to be that pattern, right? And I think a famous example of this, especially if you have kids or have had younger children around over the last decade or so, is maybe longer, is the cute little kid stories if you give a mouse a cookie, right? There's all different variations on it. There's, if you I can't remember what the one is that my kids and I read not too long ago. Ended up going to the movies. Anyway, but it's a chain reaction, right? If you do this, then this is going to happen. If that happens, if this happens, then this is going to happen, right? So if A, then B, if B, then C, if C, then D. So if you give a mouse a cookie, is a chain argument. So a little bit of deductive reasoning, finding our way into kids literature, right? It's just interesting to think about. But main thing is just knowing that, we understand that pattern, we pick up on it right away. Just know that that pattern, it has to be that way, that it has to be that pattern in order for the chain argument to be valid. All right. So when we're evaluating hypothetical syllogisms, again, we've learned not all arguments are sound, even if they are valid. So we had we looked at the form for a modus ponens, the form of a modus tollens, and the pattern, the form for a chain argument. Again, if it follows the correct pattern for each one, it's valid. If the premises are true, then it's sound, right? All right. So again, just deductive arguments, another way that we present information and are presented with information that we have to sift through to determine if it's acceptable, if we can use that information to then inform our own point of view, our own worldview, possibly use that information to make decisions and create a course of action. Just like all of the other things that we've looked at, this one, deductive arguments, they not only involve accuracy, but they also involve specific logical form, specific logical patterns. And so when you are presented with information that takes on the appearance of a deductive argument, you want to make sure you're thinking about, is this following the correct pattern of logic? So that I then know it's okay to start examining the statements themselves, right? Okay, so our critical thinking issue here at the end of Chapter 8 is perspectives on the death penalty. We are not doing this one for homework this week, but I invite you to still read the two articles. It's very interesting set of ideas that are presented. If you have any questions about anything here in Chapter 8 that we've covered, feel free to reach out. And again, you can go ahead and read through the other half of Chapter 8 if you want. And you can reach out to me about that information as well, but certainly don't feel like you have to. Covering just the sections that were covered here in the PowerPoint is fine, right? But if you do have questions or need anything else, don't hesitate to reach out. Otherwise, feel free to go ahead and move on.